Hi, this video is in continuation of my previous video on DC and DC shift. In this video, we'll see an illustration of DC shift or DC offset. Just to quickly recall, when we say DC, we mean a signal which has a frequency f equal to 0 Hertz. So DC corresponds to 0 Hertz frequency, and DC shift means the waveform shifting up or down along the y-axis. So the waveform is shifted upwards or downwards along the y-axis. This is called as DC shift, also called as DC offset. So also called as DC offset. And in contrast to phase shift, where we have the waveform shifted along the x-axis horizontally, that is either to the left or to the right. So let us see an illustration of DC shift or DC offset in this video. So the waveform that you have here is a cosine wave with 0 DC offset. So this is, if we can call it as y equal to cosine 2 pi ft. So this waveform has 0 DC, 0 DC offset. So the offset here is 0 because if you notice, it is centered, this waveform is centered on the x-axis, sorry, on the y-axis, which is the 0 line. Now when there is a DC offset, the waveform gets shifted up, as in this case. So the waveform now is centered on 1 instead of being centered on 0. That means it is having a DC component of 1 volt. Similarly, if we shift it further up, so that's having a DC offset of 2 volt because the waveform is now centered on 2. And if we go further, so that's now centered on 3 and now 2. So let's go back. So we have this now centered on 3. That means this waveform is now having a DC component of 3 volt. So I'll just write down the notation for that. So that would be y equal to, is the same cosine wave of the same frequency. So it's y cosine 2 pi ft, but there is a DC component. That means it is having a DC component of 3 volt, and the frequency of DC being 0, so this corresponds to cosine 0 or 2 pi 0 t. So if we write the general notation, 2 pi, instead of f it is 0 t. So that will be simply equal to, that's simply equal to 3, which is the DC component. So that is having a shift of 3 volt. So let's continue shifting this waveform downwards towards the negative axis. So that is now having a shift towards the negative axis. So let's pause the video here. So now the DC shift is minus 1 volt because the waveform is centered on minus 1. And in this case here, the waveform is centered on minus 3. So that would correspond to a DC offset of minus 3 volts. So if we write the expression for this, so it's y equals cosine 2 pi ft and minus 3 volt. So it's minus 3 cosine 0. So the DC offset here, DC offset equals minus 3 volts. So we see how the waveform is being shifted vertically along the y-axis depending on the amount of DC shift. When it is centered on 0, that means it has 0 DC offset. When it is centered on +1, it means it has a DC offset of 1 volt. Now it's having a DC offset of 2 and 3 and so on. And similarly, if the DC offset is negative, so here it's -1 and here it's -2 and here the DC offset is -3. So in this case here it's -3 and here it's having a DC offset of -2 and a DC offset of -1, a DC offset of 0, DC offset of +1 and DC offset of +2 and DC offset of +3 and so on. So we see that the DC offset means the waveform being shifted up or down by a certain amount, and the amount of shift corresponds to the DC level present in the signal or the DC component present in the signal, and the amount of shift is called as the DC offset. Thank you.